Hi everyone, this video is solving for a variable in a given formula. In these examples you're going to have formulas with several variables and being asked to solve for one of them. The important thing here is to understand these are like literal equations, which means that you're not going to actually be, come with a value for the variable at the end. You're just going to be expressing it in terms of the other variables in the problem. But you solve it in the same way you normally would solve an equation. So let's take a look here. So for this first one, we have I equals PRT, and we're trying to solve it for T. You might recognize the formula as a simple interest formula. To solve this for T, what it really means is we want T by itself on one side of the problem at the very end, and then no other T's appearing. So to isolate T on one side, in this case, we have I equals PRT. Remember, PRT, when you see variables next to each other, that means you're multiplying them. So to isolate T, we want to remove the PR from it. So if we're multiplying PR times T, to move it to the other side, we want to divide by PR, because that'll cancel it on both sides, because division is the opposite of multiplication. So on the right side here, the PR will cancel out, and on the left we'll have I over PR, and that's equal to T. And now I've gotten T by itself on one side and everything else on the other side, so I have this solved for T. It's actually a very quick process. The common mistake people make here is they try to force numbers into the problem, which aren't really the case when we're trying to solve like this. So make sure you understand what you're trying to solve for. It's solving for T in terms of the other variables in the problem. The second one here, we have P equals 2L plus 2W, and we're trying to solve it for L. So I'm trying to get L by itself on one side, which means I have to move all the other terms that don't have L into it to the other side. So if I wanted to move this so only L's were on this right side, I want to move that 2W over. And if I have a positive 2W, right, I'm adding 2W, how do I move it to the other side? Well, I have to subtract 2W from each side. I'm going to subtract 2W from this side. So for this left side, P and 2W are not like terms, so you're going to write it as P minus 2W, just as is with the correct sign. It's a positive P, so it stays positive. It's a negative 2W, so it's minus 2W. It's equal to, on the right side, I have 2L, right? Because the 2W minus 2W cancels out, right? And that's why we did that. So now we're left with P minus 2W equals 2L. So to solve this for L, this is 2 times L. What do you think we should do? Well, we should divide both sides by 2. I'm going to divide this entire side by 2. Make sure you're dividing the entire side. So I'm left with P minus 2W over 2 is equal to, the 2's cancel here, I'm just left with L. Now, we solve for L. L's by itself on one side, right? And there's no other L's showing up in the problem. So we've gotten L by itself. You could leave it like this. Now the question becomes, can I simplify this any further or in a different way? Sometimes people think they can just cancel the 2's here, which you're not allowed to do because we have this subtraction up here. Those terms are stuck together forever by a subtraction sign. I kind of talk about them like they're married forever by a subtraction sign. So the way you can split this is you could put P over 2 minus 2W over 2, because really what's happening when you divide by 2 is each term is getting divided by 2. When we say divide this entire side. So the equivalent to this would be, or you could say P over 2 minus 2W over 2 is equal to L. Those are equivalent. And then now, because we only have multiplication in the numerator of the fraction, we can cancel with the division of 2, which cancels here, so I get P over 2 minus W is equal to L. Alright, so one or the other here is okay. They're both acceptable answers. If I don't ask you to divide it any further, this is fine, to leave that first one. But this might be more handy when we talk about the equations of lines in a little bit, and we'll talk about that in a minute. The important thing to notice, though, is you can't just cancel the 2's. Otherwise, you'd end up with just P minus W there, which is not the same as what we got for our answer. All right, so if you are dividing by some sort of constant to both sides, you can divide each term by the constant, is what this really shows. And then you can cancel if that helps. The next example down here, letter C, we have A equals 1/2 BH, and we're trying to solve this for B. All right, solving this for B means I want B by itself on one side. Now, I have an equation with fractions. Typically, when you have an equation with fractions, the first thing you want to do is remove fractions. And to remove fractions, we usually multiply both sides of the equation by the LCD. In this case, the LCD, since I only have one fraction, is 2. So I'm going to multiply by 2 to this side, and then multiplying by 2 to the right side as well. So on the left side I have 2a, it just stays 2a. Because I'm trying to clear out this fraction. 2 times 1/2 bh. Remember, this is all one term, so the 2 only gets multiplied to this one time. So these 2's actually are going to end up canceling out, right? So I have 2a equals, I'll write it out so you can see it, 2 times 1/2 bh. And then these 2's, this 2 will cancel with this 2 here. We multiply 2 times 1/2. 2 divided by 2 will give you 1, right? So it'll cancel to a 1. And you're still left with 1 times 1 bh. It's not distributing. You can't bring a 2 through here. You only distribute if you have addition or subtraction inside parentheses. So I'm left with this 2a equals, we have 1 times 1 is 1, times bh will just be bh. Since I'm trying to solve this for b, right, we're solving this for b, you have b times h. To get rid of the h, you'll divide both sides by h. So you end up with 2a over h is equal to b. You solve for b, it's by itself on one side of the equation. There are no other b's showing up, so you know you solved for it. So b is equal to 2a over h. This is a very common final exam type problem that people make a mistake on. Letter D here, it says 3x minus 2y equals 5. We're trying to solve it for y. So you may have seen this before, or something similar to this when you're solving for y in linear equations. This, you know, if you have an x and a y here, typically you'll see this when you're graphing lines. But we're trying to solve this for y. And to solve this for y, that means I want y by itself on one side. So the first thing I want to do is remove this 3x from the left side. So this is a positive 3x minus 2y equals 5. This is positive. To move it to the other side, we want to subtract 3x from each side. So minus 3x and minus 3x. On the left side, these cancel, right? And that's why I did it. And I'm left with negative 2y. Make sure you have a negative with that 2y. Don't lose that negative sign. It's equal to, on the right side, 5 minus 3x is a way you could write this. Typically, when we do this for lines, we want the variable with x in it to come first, or the term with x in it to come first. So I'm going to write this as negative 3x, and that's a positive 5, so plus 5. So remember, keep the sign with the term. So you could write it as 5 minus 3x, but it's the same as saying negative 3x and then plus 5. If this 5 was negative, it would be a minus 5 there. If this was a plus 3x, it would be a positive 3x there. And now I want to solve this for y. So what should I do? Well, I want to divide this by negative 2, right? This is negative 2 times y, so to remove it, you divide by negative 2. Remember, I say divide by negative 2 to both sides. You could say it divide by negative 2 to each term. That's really what we did up here in this previous example. So I'm dividing each term by negative 2. So the negative over a negative cancels to a positive here, makes it positive y, and that's what we want. You can't leave it as a negative, so that's why we divided by a negative 2, so it cancels the negative as well. So we have positive y equals, here I have a negative 3 over negative 2. Well, a negative divided by negative makes it a positive. And then 3 over 2, if it doesn't reduce any further, I'd keep it as a fraction. So we have 3 halves x. The x can be written in the numerator or right next to it. It can't be in the denominator, because remember the x means multiplication there, or the 3x means multiplication there. So that x should be either next to 3 or right next to the fraction. It cannot be in the denominator. For the next term, I have a positive 5 divided by a negative 2. A positive divided by a negative will make this negative. And I'd leave that as a fraction as 5 halves. A lot of times you might see in the directions, especially if you're working in my math lab, leave your answer on the form of fractions for any values in the problem. You would want to leave it like this. If it asks you to convert these to decimals, you could. But if it doesn't ask you to, I expect you to leave it as fractions. So we have y equals 3 halves x minus 5 halves. Let's take a look at E and F, which are some unique cases. They're a little different than the ones we did previously here. So for letter E, we have 5t equals 2p plus at, and we're trying to solve this for t. So remember the goal. The goal is to get t on one side by itself and everything else to the other side. So if you have two terms that have t in here, all the t's have to be brought to the same side first, and everything that doesn't have a t should be brought to the other side. The common mistake people make, which is not correct, is to try to divide both sides of this by 5, and then they say they solve for t. It's not solved for if t still appears somewhere else in the problem. There can only be one t in this at the very end. So what we're going to do is we're going to subtract at from each side. And the reason I'm doing that is because I want to bring all the t's together to the left side. Everything that doesn't have a t will stay on the right side. So I have 5t minus at. You can't combine those, so I'm going to write it as 5t minus at. And it's equal to, right, these cancel out, so it's just equal to 2p. So I've got my t's together on one side. That's the first part of the goal. The second part of this is really what we use our factoring for. If you have both of these terms that have a common factor of t in it, you can factor t out. In other words, like you're factoring out a GCF. So I'm going to factor t out from this side, because remember, I want to solve for t. That's why I'm factoring t out. I need a single t by itself, and this is how you do it. So you factor t out of here, and you're left with 5t. Factoring out the t is just 5. Minus at, factoring out the t is just a. So you have t times, in parentheses, 5 minus a is equal to 2p. You may have heard me just say this, but remember, this is t times this now. Right when you factor, you made it a multiplication. So how do I get rid of the 5 minus a? So I'm just left with t here. Well, if this is multiplication, to get rid of it, you want to divide by 5 minus a to each side. Divide by 5 minus a. They cancel on the right side, and then you're left with t equals, you'll have 2p over 5 minus a. None of these cancel. You can't cancel any of it at all, so it stays as t equals 2p over 5 minus a. So if the variable shows up more than once in the problem, you want to try to get them to the same side and then factor out that variable, because that'll let you divide over and leave the variable by itself. It's a little tricky, something you may not be familiar with, but the common mistake people make is they try to divide at the beginning, and then you'll still have t on both sides. The other common mistake people make is they do this first part correctly, where they factor it out, but then they distribute back in and they've undone what they just did. So make sure once you do that, then you're dividing. The next example here, we got 2x over x plus 6 is equal to b. We want to solve this for x. So first off, you have these x's in the denominators. What you can't do is you cannot cancel these x's. If there's addition or subtraction in the denominator here, you can't cancel with this x in the numerator. You can only cancel if these were factors. In other words, they were being multiplied in the denominator and the numerator. Then you can cancel. So we have 2x over x plus 6. I'm just going to write it again so it's easier to see. Is equal to b. So I need to get that variable of x out of the denominator, that x plus 6. And the way we do this, there's one of two ways. You can multiply by an LCD, which you might not be familiar with just yet. But you could write this as b over 1. When you have a fraction equal to a fraction, we know how to solve this. You cross multiply. So we can do 2x times 1, which gives us 2x, is equal to x plus 6 times b, which I'll write as b times x plus 6. Now, remember the reason why we cross multiply. You only cross multiply when you have a fraction equal to a fraction. It's a way of clearing fractions so it's easier to solve an equation. All right, so that's what cross multiplying really does. So once I've cross multiplied, now everything is on the same level, which is good because I need my x's together on one side of the equation, which means I have to combine them on the same level. I'm trying to do kind of what I did in this previous problem. So how do I get to this x that's inside of here? To move it over, you don't want to divide by x plus 6 because then you're back to here. To move this over, you really need to distribute b in. So I'm going to distribute b through here. And end up with 2x equals, this will be b times x, which is bx. And then b times a positive 6 will be plus 6b. And now I can get the x's together to the same side. The easiest way to do this is to move bx over to the left side because there's already x's over there. If you move 2x to the right, then you'd have to move the 6b over to the left. You'll get the same answer, be in equivalent form, but it'll take you a couple more steps. So I want to get x's to one side. I'm going to move the bx to the left side to move along with the other x. So I'm going to subtract bx. So I'm left with 2x minus bx is equal to, these cancel, and I just have 6b. Once I have that, now my x's are all together on one side. Everything that doesn't have an x is on the other side. So now I can factor out GCF here of x. I'm left with 2 minus b is equal to 6b. And now I have a single x in the problem, which remember, that's what I wanted. I had to have a single x on one side. So now I have only one x in the problem. I'm trying to solve for this x. This is x times 2 minus b. So to remove the 2 minus b, we divide by it. Divide by 2 minus b. These cancel out. You're left with x equals 6b over 2 minus b. And you can't cancel those b's for the same reason why you couldn't cancel the x's at the very beginning here. These b's, this isn't being multiplied down here. If it was 2 times b, then you could cancel them out. But if it's addition or subtraction, you can't cancel with the numerator unless they're the exact same addition or subtraction being multiplied through. In other words, same factor. But we talk about that in the next section. So Making sure you know you can't cancel that is very important. You only could cancel it with multiplication down there. So that's solving some literal equations using factoring. This comes up in a couple other ways. We'll do a few more here. If I was to solve this one, you might want to pause these and try them on your own, just so you can, work through these on your own before watching the solution. So I'd pause it now, try G and H, and then come back and watch the video. So for this first one, we have 7 over m is equal to 3t plus 4, and we're trying to solve this for m. Solving for m means I want m by itself. Well, as of right now, the m's in the denominator, and I want to get that out of the denominator into the numerator. In other words, when I solve the equation, I want to clear the fractions first. So the first thing you would do, right, is if I have, this is 7m equals 3t plus 4, if I want to get m out of the denominator, I'm going to multiply by the LCD, in this case, which is m. So I'm going to multiply by m to every term. You can say to both sides, but that really means to every term. So if I multiply everything by m, in this first term, m times 7 over m, the m's cancel. That's why I did it. The goal is to clear fractions. Remember, when you're solving an equation with fractions, first thing you typically want to do is clear fractions by multiplying by the LCD. In this case, the LCD is m. So the m's cancel. I end up with 7 equals m times 3t, I'll write as 3mt, plus, here I've got m times 4, which I'll say is plus 4m. Now, the goal is to solve for m. Right now, I need to get all my m's to the same side. I have that, which is good. So how do I get m out of here? Well, these terms have m in common, so you're going to factor it out. So you have 7 equals, this will be m times 3t, right, if you factor m out of the first part, plus 4m, factoring out the m's, gives you plus 4. Now, you might have noticed if you just multiply this whole side by m, you could have left it there at the very beginning, but you might not have recognized it right away, so that's why I didn't show it. Once you're here, solving for m, what do? Well, you divide by 3t plus 4. You divide by 3t plus 4. So you end up with 7 over 3t plus 4 is equal to m, because these cancel out. And does that simplify? Well, there's nothing else you can do to it. The 3t is married to that 4 by that plus sign. Nothing will cancel there. So m equals 7 over 3t plus 4. For letter H here, you have an equation with fractions. They're asking us to solve it for y. Y is in the denominator. The first thing I would do, though, is try to clear the fractions out. Make this easier to solve. So you want to find the LCD. The LCD in this case, x times y times z, is the least common denominator for all three fractions. So I'm going to multiply by x times y times z to each fraction here in order to clear fractions out. So if I have xyz times 3 over x plus xyz times 2 over y equals xyz times 1 over z. And we'll simplify. To simplify this, remember, the reason we're doing this is to clear out fractions. So we're going to divide out common factors and then multiply by whatever's left. So xyz times 3 over x, the x's will cancel with the numerator and denominator, and you're left with 3 times yz. Unless you'll put over 1 here, but you don't want the fraction anymore, right? The x's cancel. Anything divided by 1 is just itself, so you have 3yz. Plus the second one here, the y's will cancel, that's the common factor, and you're left with 2 times xz. And it's equal to here, the z's cancel, you're left with x times y times 1, which will just be 1xy, which I can just write as xy. Now remember the goal. The goal is to solve for y. So if we want to solve for y, we want y's to one side, everything that doesn't have y to the other side. So I've got 3yz plus 2xz equals xy. This already has a y on this side, so I'm going to move this term with the y in it to the other side to join it. So this is positive, so to move it over, I subtract 3yz, subtract 3yz. These cancel, and I'm left with 2xz equals here xy minus 3yz. I'm just going to write next to each other. So xy minus 3yz, be consistent with the sign. Xy was positive, negative 3yz was negative. And then to solve this, remember, we want to solve for y, so we want a single y in the problem. So now that all the y's are on the same side, now I'm able to factor y out. So I have 2xz equals, now we can factor y from here. We factor y out, xy, factoring out the y is just x, minus 3yz, factoring out the y is just minus 3z. And then solving this for y, now to get y alone, this is y times x minus 3z, so to get it by itself, you divide by x minus 3z, divide by x minus 3z. End up with 2xz over x minus 3z is equal to, these cancel out, it's just equal to y. And then does any of that cancel? Well, we can't cancel any of this because remember, that's x minus 3z, they're not individual factors, so it's not going to cancel with the numerator at all. So we leave it like that. The last couple examples are just here to remind you how to solve for y equals mx plus b form. Remember, y equals mx plus b form. This is the equation of a line. M is typically the slope, b is the y-intercept. We're not really at the point in the course where we talk about that yet, but it's something that might be helpful to know either now as a refresher or as a new thing going forward if you've forgotten, because you will use it later. So basically though, this is just saying solve for y. That's the direction. So get y by itself on one side. So for letter A here, we got negative 2x plus 4/3 y equals negative 12. And there's two ways you can approach this. We'll kind of approach it the same way we talked about before. If I have an equation with fractions, the first thing you might want to do is clear fractions out. To clear fractions, you need the LCD of the entire equation. The LCD in this case, there's only one denominator, which is 3, so the least common denominator is 3. And what do you do with the 3? Well, you multiply it to each term. So you'd have 3 times negative 2x plus 3 times 4/3 y equals 3 times negative 12. Make sure you have those parentheses there because it's not subtraction, right? It's multiplication. And 3 times negative 2x. So if it doesn't cancel out, the denominator, you just multiply the values together. So 3 times negative 2x is negative 6x. 3 times the 4/3 y, well, the 3's cancel. So it's really 1 times 4y, which is just going to be plus 4y. And it's equal to 3 times negative 12, which is negative 36. Don't cancel anything here, right? This isn't in the denominator. You're just multiplying if there's no fraction. Once you have this, now you want to solve for y like we typically would. Y is on one side, everything that doesn't have y to the other. In this case, the 4y is the only term that has y, so I really want to move this negative 6x to the other side. To do that, I'm going to add 6x using the opposite operation and add 6x. These cancel out here on the left. We have the positive 4y, so you have 4y equals, this is a positive 6x minus 36. Because I want this mx plus b form, you want the x's coming first. These are not like terms, you can't combine them. So positive 6x you write as just 6x. Negative 36 is minus 36. Keep the sign with the term. Last thing to solve for y, make sure you want y by itself. You're going to divide both sides here by whatever's in front of y. So you divide by 4. Divide each term by 4, right? When I say divide both sides by 4, it's divide each term. Remember, terms are separated by addition or subtraction. So on the left, 4's cancel, end up with y equals. On the right here, 6 divided by 4. If that reduces, you should reduce it. And 6 divided by 4 reduces by 2 in the numerator and denominator. 6 divided by 2 gives me 3. 4 divided by 2 gives me 2. So it's 3 halves x, or you put the x next to the 3. Just don't put it in the denominator. Minus 36 divided by 4. Negative over positive keeps it negative, so the minus sign's good. 36 divided by 4 is minus 9. And then that's it. You've got it. Don't put this all over 2, right? These are individual fractions, so keep those as they are. So y equals 3 halves x minus 9. If you approach this slightly differently at the very beginning, you might have added the 2x over because you saw the mx plus b form, but then you'd have to still multiply both sides by the LCD of 3 to clear fractions. You would end up in the same place, just a little different in the order. You may want to try the next one on your own. Pause the video and take a look at it. For letter B here, the LCD, right? We have an equation with fractions. We want the LCD so we can clear fractions. The LCD in this case is the smallest number 3 and 2 both can go into evenly. Just 6. All right, so don't just use 3 or just use 2. It's not about what's in front of the y. It's really about, you need to clear all the fractions to make it easier to work with. So the LCD is 6, and I multiply it to every term. So I would have 6 times 2/3 x minus 6 times 1/2 y equals 6 times 7. And then you want to clear fractions. So here you've got 6 divided by 3, which gives you 2, and 2 times 2x gives you 4x. So remember, you would sometimes divide this. They don't just cancel completely. You're left with 6 divided by 3 gives you 2. 2 times 2x, now you multiply inside, gives you 4x. Minus, here we have 6 times 1/2 y, so the 6 divided by 2 becomes a 3. And it's negative 3 times 1y, which is left over, which makes this negative 3y. So you always cancel with the denominator and then multiply through the numerator. And this is equal to 6 times 7. Remember, this isn't a fraction, you just multiply them together. That's 42. And now fractions are gone, which is good because it makes it easier to work with the problem. So we have 4x minus 3y equals 42. I'm trying to solve for y because remember I want the y equals mx plus b form. So I want to move the x term to the other side. So to move the 4x over, I'll subtract 4x from each side. On the left side they cancel. I'm left with negative 3y equals 42 minus 4x. You could write it that way except for we want the mx plus b form, so we want the x's coming first, the constants coming last. Because remember, m and b are just constants. So I'm going to write this as negative 4x. This is a positive 42, so plus 42. And then we want to solve this for y, so we'll divide both sides by the coefficient of y, which is dividing by negative 3, right? It's negative 3 times y. To get rid of multiplication, you divide by it. So divide by negative 3, and you're doing that to each term, remember, because you're doing it to both sides. It's really every term on both sides. Negative 3's cancel, end up with a positive y, which is what you need. All right. If it's negative y here, then you still would have to divide by a negative 1 at the end. So it's a positive y equals negative over negative makes it a positive. 4 divided by 3 doesn't simplify any further, so I'll leave it as 4/3. You should too. So 4/3 x. And then 42 divided by negative 3, a positive over a negative makes this a negative. 42 divided by 3 is 14, so your y equals 4/3 x and then minus 14. And that's the y equals mx plus b form. If I asked you what m was, m is the slope, which is 4/3, right? B is the y-intercept, 0 comma b, typically is how we'll say it, but it's negative 14. That's how it fits this form. In this case, you had 3/2 would be your m, right? And your b would be the negative 9. That's how it fits this form. So it doesn't have to be a plus sign in front of b, it's just it's telling you that there's a number there. B could be a positive or a negative. In this case, b was negative for both of them. The only other thing I'd mention is that you'd want to keep this as a fraction unless we specify to do otherwise. Otherwise, you may get an incorrect answer. 4/3 does not come out to an exact value you could write as a decimal. 3/2, does, but you might use this later as a fraction. So make sure you're answering in the way that we ask you to. All right. So hopefully this helped in solving variables and literal equations. It's something that takes a little practice. It's just really solving the same process you normally would to solve an equation. You're just going to leave the variables in there as they are. So hope this helps.